On this channel, we provide useful programming information with practical code examples. This time, it's about DataView in TypeScript. We will explain DataView in TypeScript from the basics to practical usage, step by step. Enabling subtitles will make the code descriptions easier to understand. By using DataView in TypeScript, you can perform fine-grained byte-level read and write operations on an ArrayBuffer. DataView is extremely useful for low-level binary processing such as protocol implementation, binary file analysis, and sending, receiving binary data over WebSocket. ArrayBuffer is a fundamental data structure used to store a fixed-length sequence of bytes. Typed array, such as uint8 array, are views that treat the buffer as an array of a specific type, where each element has a fixed type. On the other hand, DataView is a flexible view that allows you to read and write values of any data type at any offset position. Because it does not assume fixed types and allows fine-grained control at the byte level, it is suitable for analyzing binary protocols and low-level processing. The following is an example of creating an ArrayBuffer, and then creating a uint8 array, and DataView from it. In this code, two different types of views, uint8 array and DataView, are used simultaneously on a single buffer. Using DataView, you can flexibly read and write values by specifying arbitrary offsets and Endianness. DataView is an interface for manipulating an ArrayBuffer at the byte level and provides methods to read and write various types such as integers and floating point numbers. All of these methods take a byte offset as the first argument. Get reads the value at that position, and set writes the value to that position. You can also specify the Endianness with the second argument when handling 16, 32, or 64-bit data. In practice, it is safest to always specify the Endianness according to the data specification. The following example shows how to write a 32-bit integer and a 32-bit floating point number in little endian format to a buffer and then read them back in the same format. By explicitly specifying the Endianness, you can ensure compatibility with different platforms and binary specifications. Some protocols, such as those used in networking, use big endian, while many CPUs and file formats predominantly use little endian design. In DataView, if the second argument is set to true, it treats the data as little endian. If set to false or omitted, it treats it as big endian. In the following example, you can see how the byte array in memory changes when writing the same number using both big endian and little endian formats. Understanding how the byte order changes between big endian and little endian will make it much easier to analyze communication data or binary formats. DataView is excellent for reading and writing numbers, but it does not handle strings directly. It is common to encode strings using TextEncoder or TextDecoder, such as to UTF-8, then copy them into the buffer via uint8 array. The following is an example of writing a UTF-8 string to a buffer and then reading it back. By converting strings to binary and, if necessary, prepending their length, you can store variable length strings. Below, we define a simple message format containing a version number, ID, and name. We implement an encoding process to convert messages to binary data, and a decoding process to restore the original object from the binary. In this message format, the first byte stores the version, the next 4 bytes store the ID in little endian format, the following byte contains the name length, and finally, the UTF-8 encoded name is stored. This is a typical implementation for handling a basic message format containing a variable length string, and can be applied in many practical situations such as network communication or custom binary file designs. When working with binary data using DataView, there are several practical points to consider beyond simply reading and writing values, such as safety, consistent use of endianness, and proper handling of types. In particular, when handling binary data received from external sources or dealing with large integers, it is important to design your code to prevent incorrect reading and buffer overruns. Below are some useful points to remember for practical use. Boundary check. DataView throws an exception if an offset or size exceeds the buffer boundary. Always check lengths when dealing with untrusted binary data. Always specify endianness. Always explicitly and consistently specify little endian or big endian in your code. Type consistency. JavaScript numbers are 64-bit i.e. 754 floating point values. Methods like getUint 32 inches are handled appropriately, but there is no getUint 64. So special handling is required for 64-bit integers. Handling 64-bit integers. To handle 64-bit integers, you need to use big int, or manually split the value into high and low 32-bit parts. Here is a simple example of reading a 64-bit unsigned integer. By using big int, you can safely handle integers larger than 64 bits as well. Although buffer is commonly used in Node.js, it is also easy to convert between ArrayBuffer and DataView. Use the buffer property of buffer objects or the uint8 array constructor for conversion. This can be used as a tool for exchanging binary data between Node.js and browsers. DataView is a powerful mechanism for freely reading and writing binary data, particularly useful in situations where flexible control such as specifying endianness and accessing arbitrary positions is needed. By combining ArrayBuffer, TypedArray, and DataView, you can flexibly and accurately handle binary data with TypeScript, enabling a wide range of use cases from protocol implementation to file analysis. By also incorporating string encoding and handling of 64-bit integers as needed, you can achieve even more practical binary operations. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching until the end. Please subscribe to the channel and look forward to the next video.